Bari in question 3. In the diagram below, P, Q, R, and S are the vertices of a quadrilateral PQRS. So fortunately, this is drawn for us. I'm not very good with this, but I will try my best. We have R, 0 and 3, S, T and K, P, 7 and 4, Q, 6 and 6. Bari, in the diagram, P, Q, R, and S are the vertices of a quadrilateral PQRS. In 3.1, they say calculate the length of PQ. Find PQ. Leave your answer in set form. 3.2 Bari, if T with the coordinates 7.5 is the midpoint of QS, find coordinates of S. If T with the coordinates 7.5 is the midpoint of QS, find the coordinates of S. 3.3, if the coordinates of S are 1 and 1, if S is 1 and 1, show that PR equals QS. Okay. 3.4, show that QR is perpendicular to RS. The last one, but not the least, hence what type of a special quadrilateral is PQRS? What type of a quadrilateral is PQRS? Motivate your answer, that's fine. 3.6, they say find the size of RSQ. Very good, right? We will try to solve that. Now, how are we going to do this? How do we find the distance of PQ, the length of PQ? The distance formula, of course. We are using the distance formula. We know that the distance of PQ, x2 minus x1, y2 minus y1. P with the coordinates x1, y1, x2, y2. This will be 6 minus 7. This will be 6 minus 4. This will be minus 1 squared, 2 squared, 1 plus 4 root 5. They said we should leave our answer in set form. Okay. And then we go to 3.2. If T with those coordinates is the midpoint of QS, find the coordinates of S. You are the midpoint when at T of what? Q and S. So, hey, we are having a problem. What the coordinates that T? 7.5, 7.5, and a midpoint. And a midpoint wa X, midpoint wa Y. Rabata, we can say X2, Y2, X1, Y1. So we can say X equals X1 plus X2 divided by 2 y1 plus y2 divided by 2. Midpoint was x, 7.5. x1, 6. x2, 3 over 2. It's a bit of a then our midpoint was x, 7.5. Our x1 is 6, our x2 is 3. We are dividing that by 2. And our midpoint was x. And our x1 plus x2 divided by 2. And our midpoint was y. And our y1 is 6 plus k divided by 2. Cross multiply. Autobanal 7.5 times 2, 6 plus 3, numerator, denominator. We are fine with this. Cross multiply 6 plus k, this into this once. 1 equals t, 1 equals k. Are we fine? Okay. So, A.
Money more cross multiply. Okay, so 6 and
6 feet.
6.
What you cross multiplier?
A.
Have a share, have a cross multiply.
What is a 6 minus 6 and
Have a cross multiply. Have a cross multiply. Or 107.5 times 2 equals 1 times 6 plus t.
Oh, they born.
I can say now, now
But look at the conclusion.
I can say that's why nanigate at you. Give us 6 plus t, beggar t equals 1. In now. Right, so the coordinates are s, k, 1 and 1. Okay. Now that we are fine with the coordinates of s, let's go to 3.3. Let's go to 3.3. Abuk? Hey, but if S is 1 and 1, show that PR equals QS. PR equals QS. Okay, this equals this and this equals that. Okay, I know what type of a quadrilateral is that, but that's fine. Come on, Jama, what is it that we are going to show here? If PR equals QS, the distance must be the same. So the distance of PR must be the same as the distance of QS. So what I'm going to do is the following. This must be equals to the distance of QS. So that when I do this, so that I can say this is equals to the distance of QR and do this. Very good. And then from here I can work out PR, where are you? PR, x1, y1, x2, y2. So that would be 0 minus 7 squared. That would be 3 minus 4 squared. Remember, this is 0 and 3, 7 and 4. x2, y2, x1, y1. My x2, 0 minus 7. My y2, 3 minus 4. Equal QR, where are you? X2, that would be 1 minus 6. Y2, that would be 1 minus 6. Minus 7 squared minus 1 squared. Minus 5 squared minus 5 squared.
I see QR.
Q
Wenze SQS.
Sabo. QR again. QR. So I will have my x2 as 0 minus 6, my y2 as 3 minus 6, minus 6 minus 3. Again, this will be 36 plus 9. And 36 plus 9, that should give us 45. Again? Yes, that should give us 45. And on this side, we have 7 squared, that is 49, minus plus 1. 7 squared is 49 again? Yes, it's 49. 49 plus 1, which is square root of 50. Are they equal in dozen? 36 plus 9, that is 45. Yes. And then 7 squared is 49 plus 1, which is root 50. Can distance say a hand? We can't because we are saying that PR equals QS. If S is 1 and 1, show that PR equals QS. So ka distance ya hand. That's fine. PR.
When they QR and make QS, show that PR is equals to QS and QR man.
PR. Wena we. Nekenza hantle kitse QS. How we can get a coordinate S, can get coordinated R.
Can. Distance QR.
Go, your offer. You want accounting in time. Go get the work accounting. Or you have to entire. Linakata. QS again. QS. K 1 minus 6 1 minus 6 minus 5 minus 5 ever 25 plus 25, which is root 50. Therefore PR equals QS. Hela talantaya win. La talantaya. Right. Harriet 3.4. What type of a quadrilateral is PQRS? Where PR equals QS. What type of a quadrilateral is this? Is it a rectangle? Diagonals bisect one another. Okay, this is true. RQ is parallel to SP. Rectangle will require that all angles are equals to 90 degrees. Diagonals bisect one another. I will assume that it is a rectangle for the fact that diagonals bisect, all angles are equals to 90 degrees. RQ must be parallel to PS and RS must be parallel to QP. And those criteria falls very much to a rectangle. I will assume that it is without any further debate. That was 3.5 because it was 3.4.
3.5.
No, man, it's 3.5. No, skip 3.4. Show that QR is perpendicular to RS. QR is perpendicular to RS.
RS.
I know that the gradient of QR multiplied by the gradient of RS must give us negative 1. So how about the gradient of QR? My QR, I will have 0 minus, sorry, 3.
Minus 6.
3 minus 6 all over
0 minus 6.
0 minus 6. This will give me minus 3 over minus 6, which is 1.5. Okay. What about the gradient of QR? We are saying the gradient of QR, it's y2 minus y1 over x2 minus x1. We are taking the coordinates of Q and R, substituting here and finding 1/2. And then the gradient, RS, until y2 minus y1, x2 minus x1. My y2 for RS,
C1 minus 4.
RS ito ba harere muna ki x1 muna ki y1 ito ba 3 minus 1 all over 0 minus 1. This is 2 over minus 1, which is minus 2. Shade 1/2 multiplied by negative 2 is equals to negative 1. I get therefore QR is perpendicular to RS. 3.5 in the series where we are now. 3.6. Find the size or calculate the size of RSQ in triangle. RSQ, find the size of angle S. RSQ. Find angle S.
Jean.
And
Triangle Jean.
here. Here na triangle here. But what are the size of angle S? Okay. And a remote QR is perpendicular to RS again. And we know that it makes an angle of 90 at R. Here an angle of 90. Okay. So if I have an angle of 90 more, and I give the size of angle S. In triangle. RSQ. RSQ. Triangle RSQ. About the angle R. And the bone QR is perpendicular to RS because it forms an angle of 90 at R. So how do I find the size here angle A? I will look at theta. And I can beta from Kala. That should be the question. How do I find that angle? How do I find that angle? Ntwapi, theorem of Pythagoras. Because hauna side na hauna side. So ang kalapili ka wata ma side. Har batele side la QR rabone na ke bukai. Ana the distance of QR. Icon the distance of QR equals x2 minus x1, y2 minus y1. Reho QR equal by 0 minus 6 equal by 3 minus 6 minus 6 squared minus 3 squared. 36 plus 9, which is 45. So another 45, root 45. Okay, Now let me try to find RS. I think RS was calculated icon. But I know that QP. Now another QP. Another QS icon. Yes, another QS I get root 50. Kopa pumlam. Kere root 50. Kopa to that right angle to triangle. To kopa wait a J. Kere, this is R. Here. Kere kinale the hypotenuse yak QS. Kere kinale QS. Kinale QS ya root 50. Kinale QR ya root 45. Right. Kebatanale angle S. Born. Trigonometric ratios. Opposite over hypotenuse. So the sine of theta equals opposite over hypotenuse, which is, what is my opposite? Root 45 all over root 50. Okay, sine of theta. I can rewrite this as root 45 over 50. And then give my sine theta again, and then I can divide by sine, and then theta will be arc sine root 45 over 50. I can do that. Root 4 over root 5 is the same as root 4 over 5. I'm just trying to apply the principles. All I'm doing there is applying the fundamental principles of algebra. So what is arc sine of root 45 over 50? And you will find a value of 71,57 degrees as the size of angle S. The size of angle S is that, and that will bring us to the end of our lesson for question 3. Number page man 45. Washuta kapa wa copper.